Good afternoon. It's Mrs. Boland with Elements of Statistics at the University of West Florida, and we are studying discrete random variables, and we are working problem number 3. Problem number 3 reads as a school newspaper reporter decides to randomly survey 18 students to see if they will attend Tet, a Vietnamese New Year festivities this year. Based on the past years, she knows that 25% of the students attend Tet festivals. We are interested in the number of students who will attend the festivals. Part A. How many of the 18 students do we expect to attend the festivals? Or festivities, rather, sorry. So the first thing we need to look at is what type of distribution is this? Well, the bottom line is as we're reading this, we can say that we have either 1, 2, 3, or actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 possible outcomes, because we're only going to talk to 18 students. So either all 18 students are going to be going to the festivities, or none of them are going to be going to the festivities, or somewhere in between 0 and 18. We can't have 19 people going to the festivities because we're not even asking if they're going to Tet, okay? We're only asking 18. We can't have a negative number of people, right? And we can't have 1.5 people going because we're not going to accept an answer of, I'm not sure, okay? So it's either yes, no maybes. So that means it is a discrete random variable. And because there are only 2 possible choices, I'm attending or I'm not attending. That tells us 2 choices: attend, not attend, success, failure, 1, 2, right, left, okay, go, stop. We have a binomial distribution. Remember, bi meaning for 2, like a bicycle. So since we only have 2 possibilities, we're going to, and each possibility is independent. We're going to say without a doubt that this is a binomial distribution, and so we will calculate any answers using binomial formulas. So the question says, how many of the 18 students do we expect to attend the festivities? The information that we need to make sure that we have is the probability of success, which is the probability of somebody attending. That's 0.25. It says 25%. Remember, we have to convert that 25% into a mathematical usable form. So we convert that into 0.25. And then we need to know how many people are in our study. We have 18. So that's our important information, of course, with the addition of knowing that we're dealing with a binomial distribution. So we're going to come back over to our notebook paper here, and we're going to write down that for problem number 3 here. So this is going to be, let's write in this color ink. We haven't done this one lately. Problem number 3, that we have our sample size. Remember, we denote sample size as n is equal to 18. The probability of a success is equal to 0.25. And question A is, what is our expected value? Remember, expected value, mean and average are all the same thing. So that is mu. And mu for the binomial is equal to NP. Okay? So our N is equal to 18. Our P is equal to 0.25. And we're just going to grab our handy dandy calculator and we're going to put in 18 times 0.25, and we get that is equal to 4.5. So let's go back and fill that answer in, and we'll say our expected value is 4.5 people, and let's check our, I haven't been logged in quick enough. There we go. And it says that it is correct. Now the next question says, find the probability that X, or exactly 1 student, will attend. So that means we're looking for part B right here. And it says we want to know the probability that X is equal to 1, or in other words, exactly 1 student attends Tet. So that's the probability that exactly, one student attends TET. Okay, that's what we're looking for. Now remember, I said that this is a binomial, or we decided together, binomial distribution. Okay, so it's a binomial distribution. That means we have 3 ways we can calculate this answer. 3 ways to calculate the answer. Or 3 ways that we can look at, okay? The first way is using the binomial table. So part 1 here is the binomial table. Okay, so we have the binomial table, and we can only use that if our n, because the tables that we have provided for this class are less than or equal to 20. So right now we have 18, which is less than or equal to 20. So yep, we've got that met. The next part that we have to make sure is that our probability is a multiple of 5%, okay? And 25% is obviously a multiple of 5%. So, oops, let's see here. I'm not sure even where that came from. Let's see here. Which way am I going? I've been using the same sheet of paper for a while. I think I switched pages. Hang tight. Let me see where I'm at here. We need to go back to, yep, discrete. Here we go. Sorry about that. Alrighty. So, 25 is a multiple of 5. So that means we can use our tables. So we're going to look at our tables, and we have, in this case, we have n is 25, or 18 rather. Our probability of a success is 0.25, and we're choosing one person. Okay, we're choosing one success. So this is the information in the order that it needs to be looked at in our tables. Now in class, you know, I always said that we had n, and then we have our probability, and then we had x. Well, our tables are set up a little bit differently. Our tables are set up where we have n, probability, and then an r, okay? So when you're using your probability tables that we provided for this class, make sure you remember that x is equal to r. Okay, so let's go find our tables. Here's our tables. And right here, you can see that we have 18. Let me see if I can highlight that. We have n is right there. Oops, not all the way over, just right there. That's n. And so here we have n is 17, n is 18, and n is 19. So for our example, n is equal to 18. So this is the section that we are going to be looking for our probability. Okay, this is where we're going to be looking. The next thing we need to look at is our x, which we call r. If I can highlight it, I'm trying to highlight it. It's next to the n up here. There we go. And so in our case, that is going to be the value 1. Okay, it's the value 1 because we're choosing one student to attend. We want to know what's the probability that exactly one student attends TET. The next thing we need to look at is our probability, which is right along the very top. Okay, here's P. Whoops. P at the very top. So we're going to be looking for a probability of 0.25. Now we're going to identify the intersection where 18, chosen 18, one person intersects with the probability of 25. And that number is right here at 0.034. So what is the probability that exactly one person out of 18 that we talked to will attend TET? 0.034 or 3.4%. Okay, so let's go over and put in our answer. It would be over here. There we go. oops, oh, we already did that, that's right. So right here is 0.034. We're going to hit check answer, and we are correct. Now I want to show you another way to calculate this, okay? So, because sometimes we end up with a probability that's not a multiple of 5. And if we don't end up having a probability that is on this particular chart, how in the world do we solve that problem? Well, let's use the binomial formula. So the binomial formula is going to look like this. So option number 2, and we're going to go option number 2 right here, is the binomial formula. So we're just going to scroll on up a little bit, and this is going to be the, binomial formula. Alrighty, so here we are for the binomial formula, and the binomial formula looks just like this. It is n choose x times the probability of a success raised to the number of successes times the probability of a failure raised to the number of failures. So that's what our formula looks like. Remember, for this particular problem, we have n is equal to 18. We have, not q, we have p is equal to 0.25. So that means, and we're looking for x equals exactly 1. So x is the number of successes. How many failures are we going to have? We're going to have n minus x number of failures, which is 18 minus 1, which is 17 failures, which is what we're expecting. And then we also need to know what q is. I shifted, sorry about that. So then we have q, which is equal to 1 minus p, which is equal to 0.75. Alrighty, so that is our information that we need to plug in. So let's go ahead and plug this in. So we end up with 18 choose 1 success times the probability of a success, 0.25. We're going to raise that probability of success to the power of how many successes we're going to have. In this case, we have 1 success because we have 1 student attending TET. Then we have multiplied by 0.75 times the, raised to the number of failures. The number of failures we have is 17. Alrighty, so let's break this down into some more math formulas. Let's solve what is 18 choose 1 first. So 18 choose 1 is equal to 18 factorial divided by 1 factorial times 18 minus 1 factorial, okay? So that is going to be equal to 18 times 17 factorial divided by 1 factorial is just 1, so we're going to leave that part, divided by 17 factorial. Well, now we have 17 factorial divided by 17 factorial, so those two factor out, so we are left with just 18. So the first part of our formula right here, is simply the number 18. So let's rewrite our formula with the information that we know, and let's do some math. All right, so now we have 18 times, what's 0.25? What is 0.25 raised to the first power? Okay, the probability of success is 0.25 raised to the first power, and the number of successes, which is just 1, that's going to just be 0.25, right? So this is going to be times 0.25. Now, times the probability of a failure, 75, raised to how many failures? 17. So now we can put that in our calculator, and I'm going to demonstrate how to put this in our calculator. so that you can see, because not everybody knows how to do all of this. So let me see here. Did I hit the wrong button? This should just, let me hit run, I guess, is what I need to do. There we go. So here is our handy dandy TI-84. And I'm going to shift my TI-84 over here so that you can see it. And I'm going to clear my button out. And so what I'm going to put in is I'm going to go 18, and I'm going to hit my multiplication times 0.25. I'm going to hit my multiplication again, and I'm going to go, it's multiplied by 0.75, and I'm going to raise that to the 17. I'm going to hit this button right here, which is this up caret arrow, okay, and that raised, brought me to the exponent, and I'm going to put 17. I'm going to hit enter, and I end up with 0.0338. So I get, oops, let me get back over here, 0.0338. And if we were to round that to just 4 decimal places, look at that. That is 0.034. And isn't that the exact same answer that we got up here when we looked in the tables? Let's go back up to our tables. Did I put my answer down? I don't think I wrote it down here, but I know that once we looked it in the tables and we put it in over here on the board right there, the exact same answer. So that's option number 2 on how to solve this problem. Now, let's go back and let's look at option number 3. So we're going to look at option number 3 for our binomial. And option number 3 is if you have the TI-83 or TI-84, this is how you can solve it. Remember, you need to know the order of information. So we start off with our sample size, 18. The probability of success, 0.25. How many are we interested in? In this case is exactly 1. So we're going to bring up our TI-84 again. Where's it at? Right over there. And I need to shift it over. So let me see. Can I shift this over? I can't shift that over anymore. But I need to shift my calculator over because it's too far away where I can't see it. So we're going to put it over here. I'm going to hit clear. And to solve this, I will hit my second button, which is my blue button over here to the left. And I'm going to come down to VARS, V-A-R-S. And I'm going to click that. And then I'm going to scroll down using this button right here until I get to the binom PDF. And the binom PDF is what we want to use if we are finding a probability of exactly a specific number, so exactly 1. Okay, we want to use the binom PDF because it's a specific probability. Okay, so we will enter that, we'll select that. How many trials do I have? I have 18 trials. What's my probability of success? I have 0.25 probability of success. My X, I'm choosing exactly 1 success. I'm going to hit enter until I get my answer. Typically, it's 3 times. And right there again, you have 0.0338. And rounded to 4 decimal places would be 0.034. The exact same answer that we got out of the tables, the exact same answer that we got when we calculated the formula. So whatever method you want to use, as long as you're not looking at your neighbor's paper, I'm happy, okay? So if you have any questions about how you use the tables, or how you use the binomial formula, or how you use the TI-84 to find the probability of a specific value X for a binomial distribution, send me an email and I'll be happy to help you help clarify any confusion and answer any questions that you may have. Have a great day.